Now in this lecture, we are going to look at different types of linked lists. So basically, there are 4 types of linked lists that can be created. The first type is single linked list, the second type is circular single linked list, the third type is double linked list, and the fourth type is circular double linked list. First, we will start with a single linked list. In single linked list, each node in the list stores the value and reference to the next node in the list. It does not have any reference to the previous node. It can be easily seen from here that first node has a reference to the second node, and the second node has a reference to the third node, and third node has reference to the fourth node. So here in first node, we have stored the physical location of second node, which is 1, 1, 1, and in the second node, we have stored the physical location of third node, which is 2, 2, 2, and it continues like this. And we don't have any reference to the previous node. So this means that from second node we cannot come to the first node, because from second node we don't have any reference to the first node, so we can only go from second node to the third node. So this means that we have only reference to the next node. And this is because in single linked list we have only stored physical location of the next nodes in this node over here. This type of linked list is the simplest form of linked list, in which each node stores the data and reference to the next node. And you need to take into account that the last node's reference is always null in case of single linked list. Now let's continue to the second type of linked list, which is a circular single linked list. Circular single linked list is same as single linked list. The last node in case of circular single linked list reference to the first node. In case of single linked list, as we mentioned, the last node reference to null. There is no any physical location in the last node, but in case of circular single linked list, the last node always reference to the first node. So here you can easily see that the last node stores the physical location of first node. So the first node's physical location is 0, 0, 1, and in the last node we can see that first node's physical location is stored over here, which is 0, 0, 1. Basically, what's happening over here is that when we reach the last node of the linked list, we have an option of going back to the first node, which is not possible in case of single linked list. That's the only difference between single linked list and circular single linked list. And it can be seen that the name circular comes from the fact that last node always points to the first node. Basically, in this case, it creates a circle over here. So you might be interested why we need this type of single linked list. So why do we need last node to reference to the first node over here? So let's say we have a 4 chess player game, and each player plays its turns one by one. So when we reach the last player, we have to come to the first player. So in this case, for example, if we start with the yellow one, then it continues to the blue one, then it continues to the red one, then it continues to the green one, then after green one, it has to come to the yellow one. So by implementing single linked list, we cannot do this because we don't have reference from last node to the first node. And in case of single linked list, the last node's reference is null. So we face a problem over here because our game gets stuck when we reach to the last player. On the other hand, by implementing a circular linked list, we can solve this problem. So here we can implement a circular linked list in case of these 4 chess players over here. So first it starts from the first player, which is yellow player, then it continues to the second player, which is blue player over here, then it continues to the third player, which is red player over here, then it continues to the fourth player, which is green player over here. Now after reaching the fourth player, it has to come to the first player, which is yellow player. So as you can see, by implementing circular linked list, we have stored in the fourth player physical location of first player. Then when we reach the fourth player, we can straight away come to the first player over here, because in the fourth player, we have stored the reference of first player, which is the physical location of first player. So as you see, the first player physical location is 0, 0, 1, and it's stored in the last node over here, which is 0, 0, 1. And this circular traversal continues until a winner is declared in this game. So with this example, I have shown you in which cases we can implement circular single linked list. So hopefully the idea is clear about circular single linked list. So let's continue the third type of linked list, which is double linked list. This type of linked list also resembles a single linked list, but the difference is that we have references from each node to the previous node and to the next node. Now in case of first node, the previous node's reference is null in case of double linked list, and the next node's reference is reference to the second node. But in the second node, we have a reference from the second node to the first node. So the first node's physical location is 001, and we have stored it at the previous reference over here, as a previous reference over here. And the third node's physical location is 222, and we have stored it as the next node's reference over here. So in case of double linked list, we have references in both directions, previous node and the next node. But in case of single linked list, we have only reference to the next nodes. So this is the main difference between double linked list and single linked list. Now here also, you might be interested that why we need the reference to the previous node. So let's say we are at third node over here. In case of single linked list, we can only traverse to the next node. But in case of double linked list, we can come to the second node, and from second node we can come to the first node over here. So by traversing backward and forward, the double linked list provides us the extra flexibility of reversing in both directions. So let's look at the real example where we might need a double linked list. So we have learned that this type of list, based on our requirement, can go back and forward. This means that from given node we can traverse to the next node and we can come to the previous node over here. So let's say if we want to implement a music application in which we can move to the next song and previous song. It's obvious that by clicking the next button over here, we can go to the next element, and by clicking the previous button over here, we can come to the previous element, which will be in this case previous song. So if we implement just single linked list over here, we can only go to the next songs in this case. But by implementing double linked list, we can go to the next song and previous song. So if we create our double linked list like this, so the first song will reference to the second song, and in the second song we will have reference to the first song and the third song. In the third song we will have a reference to the second song and the fourth song, and it will continue like this until we reach the last song. So when we reach the last song, this next button will be disabled. So it will say that there is no node to go to the next, because the next reference of last node in case of double linked list is null, and the first node's previous reference is null over here as well. So hopefully with this example, it's clear that why we need double linked list. So in case we need backward and forward traversal, in this case we are going to implement double linked list. And finally, let's see the last type of linked list, which is a circular double linked list. So here again, it's obvious that we have similarities between double linked list and circular double linked list. The only difference is that in the first node we have previous reference, and in the last node we have next reference. So in the first node we have previous reference to the last node, and in the last node we have next reference to the first node. So as you remember, in case of double linked list, the first node's previous reference was null and the last node's next reference was null. But in case of circular double linked list, the first node's previous reference is reference to the last node, and the last node's next reference is reference to first node. So with this it's creating a circle over here. So this gives us flexibility of traversing from first node to the last node and from last node to the first node. This way it creates a circular traversing. This is why it's called circular double linked list. So let's look at how a circular double linked list works in real life. We need this type of linked list when we look through the list indefinitely while the list exists, and we can move forward and backward. So here is the real life example of circular double linked list. So here we will look at Command-Shift-Tab functionality of Mac. Mac users know that when we click this combination, we see all open applications. We can traverse through them and select one that we want to use. Right now here there are 6 applications open, which are Maps, Finder, Photos, iBooks, Calendar, and Safari browser. So when we click Command-Shift-Tab, the Mac opens this list for us and starts traverse it as we press Tab continuously. When it reaches the end of this list, in case of when it reaches to Safari, it will come to the Maps over here, and it will continue infinitely until we reach any of these applications over here. So as you see, in this case, it's implemented using double linked list. So we can go backward and forward, and we can go from last application to the first application and from first application to the last application. So if we want to implement such functionality in our applications, using double linked list will not be enough, because in this case, when we reach the end of linked list, we cannot come back to the first element due to the lack of connection between the last node and the first node. Now, in case of circular double linked list, we can implement our circular double linked list like this. So as you see from the last application, which is application 4, we have a next reference which is referencing to the first node over here, and from the first node we have previous reference which is referencing to the last node over here. So as you can see, that problem of looping indefinitely can be very easily solved by a circular double linked list. So with this, we have come to the end of this lecture, so hopefully everything is clear about 4 types of linked list. Now in our upcoming lectures, we are going to implement these 4 types of linked list separately. So we will perform all operations on these 4 types of linked list separately. So with this detailed explanation of these 4 types of linked list, you will know everything about these 4 types of linked list.